What happened when scientists released hundreds of robotic rabbits into the Everglades to track and trap invasive pythons? From mysterious swamps to cutting-edge technology, each robotic rabbit revealed secrets nature had kept hidden for decades. Join us, because what happened next shocked everyone. The silent invasion. At first glance, the Florida Everglades seem timeless. Crystal clear water stretches to the horizon, herons perch on slender reeds, and the buzzing of insects fills the dawn. Yet beneath that serene surface, a silent enemy was already rewriting the rules of survival. It arrived not with noise or fire, but with cunning, patience, and determination. Hidden among the sawgrass, the Burmese python began its silent ascent. No native predator could match its strength, and no prey had evolved to sense its presence. The snakes moved invisibly, their bodies blending into the mud and shadows. Each one fed, reproduced, and vanished into the darkness before anyone realized the scale of the invasion. Wildlife observers noticed something was wrong when the usual animals began to disappear. Raccoons, rabbits, and opossums that once scattered at the slightest noise were gone. Swamp rabbits, once common along the banks, were nearly extinct. Cameras that once captured birds in motion now showed only empty reed beds. The swamp had fallen silent, and stillness meant danger. Scientists attributed the change to a single cause: an unchecked superpredator. The Burmese python could swallow almost anything it could overpower, from small mammals to alligators. It moved for the ecosystem like a living vacuum cleaner, leaving silent devastation in its wake. A dissection revealed an adult deer inside the body of a snake, proof of just how unstoppable this invader had become. The population grew faster than anyone imagined. Each female python could lay up to 100 eggs, and almost all of them survived to adulthood. Unlike most reptiles, the mothers protected their nests, coiling around their young until they hatched. This unusual behavior in snakes gave them an advantage few species could match. What was once an exotic curiosity had become a reproductive machine. The vegetation seemed to the pythons too dense a cover to penetrate. For every snake eliminated, two more seemed to appear. They were nocturnal, elusive, and patient. Even infrared drones couldn't locate them in the labyrinth of vegetation. The battle was becoming less a matter of hunting and more a test of endurance. And humans were losing. By the early 2000s, the Everglades ecosystem had changed in ways scientists could barely document quickly enough. Raptors had fewer small mammals to feed on, scavengers struggled to find carcasses, and the flora began to shift with the loss of seed-dispersing species. What seemed like a snake problem was, in reality, the slow unraveling of a biological web that had taken millennia to form. Residents near the park began reporting strange sightings: enormous snakes slithering across roads at night, livestock vanishing without a trace, and pets found squashed in their yards. Each report seemed unbelievable until the photos started appearing. 20-foot-long snakes stretched across driveways like living shadows. Florida had become a testing ground for interspecies survival. As word spread, fear morphed into fascination. Documentaries filmed the snakes in slow motion, showcasing their unsettling grace as they moved through the water like fluid muscles. But behind the images lay a stark reality. These invaders would not stop. The Everglades had become their territory, and humans watched as their own land was silently transformed by an animal that didn't belong there. No one yet knew the extent to which the pythons would influence Florida's future, nor how many lives would be altered in the attempt to stop them. But nature would soon face another twist, one born not of instinct, but of human ingenuity. Could a single storm turn this silent conquest into something unstoppable? Join us as the mystery deepens. The storm that unleashed them. Long before the Everglades, as the Florida home became a battleground for survival, the seeds of the python invasion were quietly sown in Florida households. In the 1980s and 1990s, exotic pets were a booming trend. Vibrant and mesmerizing Burmese pythons were prized for their size and rarity. Many owners saw them as status symbols, a way to stand out at parties or in social media posts even before social media existed. But this fascination came at a price few could have foreseen. When Hurricane Andrew struck the region in 1992, it not only leveled homes and downed power lines, but also destroyed the artificial barriers humans had built between the exotic and the everyday. Terrified by the storm, some pet owners released snakes to spare them suffering. Others simply lost sight of their enormous animals as their homes were destroyed and their terrariums smashed. Floodwaters became highways, carrying these snakes into the dense, unprotected wetlands. The Everglades, a labyrinth of marshes and waterways, offered endless opportunities for creatures capable of hunting, hiding, and reproducing undisturbed. Within months, sightings began pouring in from local residents. A nearly 15-foot-long snake was seen silently slithering under a bridge. Tourists strolling along the trails caught glimpses of enormous shadows slithering underwater. Park rangers initially dismissed these occurrences as isolated anomalies, perhaps a few pets that had escaped and survived against all odds. But the reports persisted, increasing in frequency and detail. Each sighting contributed to a growing pattern, a silent warning that the swamp was becoming a sanctuary for something far more dangerous than anyone had imagined. By the late 1990s, researchers recognized that a biological transformation was underway. Without competition from natural predators in Florida, pythons reproduced at an alarming rate. Each female could lay more than 100 eggs a year, and the wetland environment offered them perfect refuge and abundant prey. Birds, mammals, and even other reptiles fell victim to their stealth. The Everglades, an already fragile ecosystem, began to show signs of imbalance. Species that had thrived for centuries now faced unsustainable predation pressure. Scientists began documenting the ecological repercussions, observing how even small disturbances could trigger a domino effect in the food chain. The human role in the crisis became painfully clear. The exotic pet culture, driven by novelty rather than responsibility, had unleashed a chain reaction with uncontrollable consequences. Every python that escaped represented the clash between human desire and natural adaptability. What began as a fascination, a way to possess a piece of the exotic, had become an unstoppable force of nature. It was a lesson in how curiosity and negligence no longer seemed impossible. The dense vegetation of the canals and mangroves made it nearly impossible for humans to locate these predators. The snakes adapted, learning to hide under floating vegetation and submerged logs. The swamp became a secret world where humans were outsiders and pythons reigned silently but firmly. Each year the problem grew, forcing conservationists and wildlife officials to confront an irreversible reality. The invasion was no longer a mere oddity. It was a full-blown ecological emergency. Could a natural disaster that seemed like an isolated tragedy become the source of one of the most widespread biological invasions in history? The storm had unleashed more than water and wind. It had set in motion a chain of events that would transform Florida's wilderness in ways no one could have predicted. The human counterattack. As the Everglades transformed into a grim realm of pythons, Florida faced an unprecedented crisis. Ordinary citizens were no longer just neighbors. They were witnesses to an invasion that grew bolder each day. Reports of snakes entering backyards, silently slithering across golf courses, and swallowing pets sparked a fear that spread faster than the reptiles themselves. Worried that time was running out, the state took an unprecedented step, turning the fight into a large-scale public effort. The Python Challenge was launched and immediately captured the public imagination. Advertisements promised cash prizes and trophies for the largest catch, while news outlets broadcast stories of heroic hunters venturing into the murky waters. Amateur adventurers arrived from all over the United States, armed with rifles, knives, and adrenaline-fueled bravery. Professional wildlife officers coordinated teams, mapping the best hunting grounds and equipping volunteers with radios, GPS trackers, and snake-handling gear. It became a mix of sport, spectacle, and a desperate attempt to control the situation. The swamp was transformed overnight. Airboats cut through hidden channels, splashing water in arcs that reflected the rising sun. Film crews, stationed along the banks, captured every moment for national television. Hunters waded through the thick sawgrass, their boots sinking into the mud as the air filled with the cries of birds startled by their presence. At night, lights swung above the swamp as search teams combed the area. Each python captured was celebrated as a victory, but for every one, several more seemed to emerge from the shadows. The data collected during the campaign revealed something chilling. Pythons were not common prey. They displayed an astonishing ability to sense danger and vanish before the hunters arrived. Some snakes had learned to avoid areas of high human activity, taking refuge in deeper channels or climbing trees. Observers noted that, in certain regions, sightings had tripled, even as hunters removed dozens of snakes. Humans were discovering the limits of their reach, and the swamp was teaching them lessons in adaptation and patience that no classroom could provide. The challenge also highlighted human ingenuity and determination. Teams began developing specialized traps, baited with heat and scent to mimic potential prey. They experimented with night vision goggles, drones, and thermal imaging to detect movement beneath the dense vegetation. Social media turned the challenge into a viral phenomenon, with hunters posting videos of enormous pythons emerging from the murky waters. The spectacle garnered national attention, but it also revealed a deeper truth. Even with technology and personnel, the swamp remained largely impenetrable. Wildlife experts observed that each human attempt altered the python's behavior in unexpected ways. The snakes began to use natural camouflage more effectively, blending in with reeds, floating vegetation, and submerged logs. Nests moved away from waterways, and hatchlings dispersed into regions previously considered uninhabitable. It became clear that the species was developing tactics in response to human interference, and each capture only made the survivors more cautious. By the end of the first major hunting season, the human counterattack had landed hundreds of snakes in museums, laboratories, and landfills, but the population seemed untouched elsewhere. The swamp had held firm, and a new question arose. Could humans truly combat a predator that had learned faster, adapted more intelligently, and spread farther than anticipated? Was this a war humans could win with courage and equipment? Or were the hunters mere witnesses to the dominance of an unstoppable force? Join us as we explore the hidden corners of history, the noses that changed the game. Hunting pythons with human sight and touch had reached its limits. The swamp only revealed its secrets to those attentive to the subtlest signs. It was then that a revolutionary idea emerged. If humans couldn't see them, perhaps animals could. Biologists began training dogs specifically to detect the faint scent trails left by pythons. It wasn't about ordinary detection. Dogs were bred and trained to track a single elusive target through the chaotic smells of the wetlands. Truman, a golden retriever with an exceptional sense of smell, became the first prototype. Alongside him, Eleanor, a border collie with extraordinary focus, proved equally capable. Together, they waded through knee-deep water and tangled vegetation, sniffing the air, the mud, and even floating logs. Each alert indicated more than just the presence of a python. It revealed movement patterns, hidden nests, and the secret corridors the snakes had created through the Everglades. The results astonished scientists. Previously unknown burrows were discovered deep within the cypress forests, places inaccessible even to the most experienced hunters. Nesting behavior, previously inferred through indirect observation, became vividly clear. Researchers could now track how the hatchlings dispersed, how the adults navigated the currents, and which areas they avoided altogether. Each successful find expanded the map of the python's territory, offering the first comprehensive view of these reptiles' vast domain. The dogs also revealed a disturbing truth about the ecosystem. The pythons weren't just hiding. They were reshaping their environment to suit their needs. They used fallen logs as hunting platforms. Dense vegetation became safe haven for the hatchlings, and even the smallest streams became corridors for stealthy movement. This level of environmental control demonstrated a sophistication few had anticipated. The Everglades were no longer simply a landscape for humans to explore. they had become a fully functional habitat dominated by apex predators. Truman and Eleanor's work transformed the search into a strategic operation. The researchers documented the snakes' movements, creating heat maps of their activity that guided future interventions. Conservationists could now predict migratory routes and identify high-risk areas for native wildlife. Every scent trail led to discoveries that had previously seemed impossible. Python eggs hidden under debris, young snakes coiled around roots, and enormous adult specimens that had eluded human detection. It became clear that the swamp had been silently recording human efforts, adapting to each intrusion, and that only dogs with exceptional senses of smell could unravel its secrets. The dogs' findings also forced a rethink of previous strategies. Humans had focused on visible snakes, often chasing the boldest individuals and overlooking the hidden majority. Truman and Eleanor revealed that most pythons avoided confrontation altogether, living in shadowy corners until the opportunity arose. By mapping their behavior, scientists began to focus not only on the snakes themselves, but also on the structures they used to survive, offering hope for more effective interventions without harming the delicate ecosystem around them. Each success, however, had a bittersweet taste. The more the dogs dug up, the more evident it became how deeply the invasion had penetrated the wetlands. The pythons had established permanent and sophisticated territories, making their eradication a Herculean task. For the first time, humans understood that this wasn't a simple hunt, but a battle of wits against a species that had learned faster and hidden itself better than anyone had imagined. What if a dog's instinct, its sense of smell against nature's most relentless predator, holds the secret to reclaiming the Everglades? Don't miss the next unexpected twist. A tele-experiment no one wanted to see. The success of canine tracking opened the door to bolder, riskier approaches. Scientists realized that understanding python behavior wasn't enough. They needed to manipulate it. The next idea, controversial and delicate, involved using live bait. Researchers built small enclosures for marsh rabbits, sheltering the animals while allowing their scent and movements to spread throughout the surrounding swamp. The goal was simple yet chilling: to attract pythons for close study. The initial results were immediate and shocking. The snakes responded decisively. Entire areas that had remained quiet became a hive of activity as they followed the scent trails. Some researchers observed more than 10 enormous pythons converging simultaneously in a single enclosure, coiling and waiting with intense patience. It became clear that the reptiles were far more coordinated than anyone had imagined. The experiment revealed not only hunting patterns, but also social behavior. Larger snakes temporarily tolerated smaller ones, creating temporary hierarchies around the bait. The data collected during these sessions was unprecedented. Motion sensors recorded attack speed, heat-sensitive cameras measured fluctuations in body temperature, and sonar equipment picked up the subtle vibrations in the water as the snakes approached. Scientists could now glimpse the world of a predator that had long operated beyond human perception. Its movement patterns, the precision of its attacks, and its ability to detect prey at much greater distances than previously thought. All of this painted a picture of a species perfectly adapted to a human-modified landscape. The success brought with it an immediate ethical backlash. Animal rights groups condemned the use of live rabbits, even in protective cages, arguing that the risk of injury or stress was unacceptable. The media quickly picked up the story, calling the experiment cruel and reckless. Under mounting pressure, the program was suspended and the rabbits were moved to safer environments. However, the knowledge gained was irreversible. All the observations confirmed that pythons could be lured and manipulated, a tantalizing fact for anyone seeking to regain control of the swamp. The discovery opened a new line of thought. If real prey could attract the snakes, what else could? The experiment suggested that pythons not only hunted opportunistically, but were also predictable. Scientists hypothesized that if they could replicate the sensory signals of prey, they could guide the snakes without endangering the live animals. The implications were enormous. It was no longer just a matter of understanding behavior, but of directing it, of turning the swamp into a controlled environment where human strategy could, at last, compete with instinct. In the wake of the controversy, some researchers saw the experiment as a model for innovation. It provided concrete evidence that even apex predators could be influenced with the right stimuli. Every strike, every approach, every coiled waiting pattern taught humans to think like a python. For the first time, a gap between observation and intervention was identified, offering hope that the invasion could be controlled without relentless hunting. Even with the experiment discontinued, the swamp itself seemed to react. The pythons quickly adapted to the presence of the baits, becoming more cautious and avoiding areas that had previously seemed safe for observation. The intelligence of these snakes was undeniable, forcing scientists to continually refine their methods. Balancing knowledge with ethical responsibility became the crucial challenge of the next phase of the fight. Could the once doomed experiment reveal the secret to defeating one of nature's deadliest predators? Let us guide you toward the unexpected. The birth of robo-rabbits. The live bait experiment, which was cut short, left scientists with both a problem and an opportunity. They had learned to manipulate pythons, but public outrage prevented the use of real animals. The solution required imagination, engineering, and a dash of audacity. The answer came in the form of robotic prey. Engineers and biologists began collaborating to create machines that could deceive predators without harming living beings. The first prototypes were simple but effective. Small, rabbit-shaped robots covered in synthetic fur were designed to mimic the subtle movements of a real animal. Sensors allowed them to move their ears, wag their tails, and move through the swamp in unpredictable patterns. Heating elements recreated the warmth of live flesh, and chemical compounds emitted odors strikingly similar to those of marsh rabbits. Initial tests in controlled enclosures demonstrated the viability of the concept. The pythons reacted as if the robots were real prey. Innovation accelerated rapidly. Each new version of the robots was equipped with solar panels to extend their operating time, and miniature cameras were implanted in their eyes to detect approaching predators. Engineers programmed subtle variations in their movements, ensuring the robots didn't repeat predictable patterns and risk losing credibility with the snakes. The machines became living data collectors, revealing routes, hiding places, and hunting strategies in ways no human observer could. The first field tests were extraordinary. Released into the Everglades at dawn, the robotic rabbits lured pythons from their hiding places almost immediately. Scientists watched enormous snakes attack and circle these mechanical decoys, displaying hunting behavior that had previously gone unnoticed. Cameras recorded every moment, showing coiling patterns, angles of attack, and even interactions between multiple snakes converging on a single robot. Each encounter presented an opportunity to map territories and predict movements, providing information that traditional tracking had never offered. Beyond tracking, the robots created a new level of safety for both humans and wildlife. By replacing live bait, researchers eliminated the ethical dilemma of using vulnerable animals, luring the snakes into observation areas. This advancement transformed the fight against the invasive species, shifting from a reactive to a proactive strategy. It was no longer a chaotic hunt, but a structured and intelligent effort to anticipate one of nature's most elusive predators. The robo-rabbits also revealed the intelligence of pythons in ways never before imagined. Some snakes approached cautiously, circling the robots before striking. Others seemed to probe their surroundings, moving in deliberate patterns to confirm the authenticity of the prey. The machines acted as both decoy and spy, exposing behaviors that had remained hidden for decades. Each successful observation contributed to a greater understanding of the swamp's dominant inhabitants, turning the Everglades into a living laboratory of dynamic strategies. However, each success brought with it a harsh reality. The python population had adapted to the environment with a sophistication that demanded constant innovation. Robots were tools, not the solution. Researchers realized that to truly control or manage the snakes, they would have to evolve alongside them, continually refining the technology to stay ahead of instinct. The swamp was teaching them a difficult lesson. Intelligence might be artificial, but nature's cunning was very real. What if machines built to mimic life became humanity's last hope, even as the pythons adapted faster than anyone imagined? Stay tuned to find out. When machines met the swamp. The morning mist hung over the Everglades, obscuring the labyrinth of canals and reeds where countless pythons had thrived for decades. Hundreds of robotic rabbits, their synthetic fur glistening faintly with dew, were deployed across the marshes. Each machine emitted a faint warmth and a scent that mimicked live swamp rabbits. For the first time, the swamp vibrated with the simultaneity of technology and nature. Scientists and engineers watched with anticipation from observation posts. Hidden among the mangroves, the robots were positioned for observation. Cameras streamed live images as the robots moved cautiously along pre-programmed routes. Every movement of a robotic ear, every shift across the mud was designed to unmask the snakes that had remained invisible for years. The first few hours passed in silence. The Everglades seemed indifferent, as if the swamp itself were studying these strange intruders. Then the movement began. A shadow glided silently underwater, its graceful body disappearing among the reeds. A massive python emerged, watching the nearest robo-rabbit. The robot's sensors detected the predator and reacted instantly, moving and twisting with astonishing realism. The snake coiled, struck, and retreated, testing the decoy as if it were alive. The cameras captured every movement. For the first time, humans could observe python behavior in real time, understanding patterns that had previously only been theorized. More snakes began to appear, drawn by the synthetic scent trails and the subtle movements of the machines. Some approached cautiously, poking their heads above the water to inspect the strange prey. Others displayed aggression, striking repeatedly and coiling powerfully around the robots. The Everglades, a place where humans had struggled to intervene, now offered an unprecedented glimpse into the lives of apex predators. The data transmitted by the robotic rabbits was revolutionary. Scientists observed how the pythons moved through the swamp, which routes they preferred, and how they interacted with one another. The machines revealed burrows hidden beneath fallen trees and submerged logs. Young snakes that had previously eluded all tracking attempts were now located, and their dispersal patterns were meticulously recorded. The scale of the invasion, once abstract and unsettling, was depicted in vivid detail for the first time. Engineers adjusted the robots in real time, sending them along new routes and modifying their behavior to elicit new responses. Some machines emitted more heat to simulate startled prey, while others stopped abruptly to appear cautious. The pythons reacted differently to each variation, demonstrating an intelligence and adaptability that required constant recalibration. The swamp had become a dynamic testing ground, a place where technology and biology met in a tense, silent dialogue. The implications of the experiment were profound. For the first time, humans could predict the movement of a predator that had seemed uncontrollable. Conservationists could identify high-risk areas for endangered wildlife, thus optimizing resource use. Researchers could plan interventions targeting specific populations without harming the ecosystem as a whole. Robotic rabbits transformed the Everglades from an unexplored wilderness into a place where strategy and observation could influence outcomes. Beyond tracking, the robots revealed subtleties in python behavior that no human had ever observed. Some snakes displayed curiosity, circling and inspecting the machines before striking. Others exhibited territorial behavior, coiling around a robot and defending it from rivals. Cameras captured these interactions with unprecedented clarity, allowing scientists to study the communication, hunting techniques, and spatial awareness of a species that had previously been virtually impossible to observe in its natural habitat. The swamp responded with a mixture of caution and curiosity. The pythons, which had been elusive for years, now revealed themselves regularly. Their patterns of concealment, hunting, and nesting became predictable enough to allow for targeted tracking. Even so, the reptiles retained a sense of dominance. Each interaction reminded the humans that while technology could illuminate and influence, it couldn't dominate a predator perfectly adapted to its environment. The Everglades remained a place ruled by instinct, knowledge, and survival. As the sun rose, bathing the canals in golden light, the robotic rabbits continued their patrols. Every snake encountered, every recorded movement, contributed to a growing understanding of the Everglades as a living, dynamic web of predators and prey. The once impenetrable and mysterious swamp had become visible and comprehensible thanks to human ingenuity. Yet the lesson was clear. The struggle to understand nature required innovation, perseverance, and respect for forces far older and more cunning than humans themselves. Ultimately, the robotic rabbits had accomplished what no hunt, no dog, and no human effort alone could have. They had transformed the swamp into a place where observation, technology, and strategy converged. Humans hadn't conquered the Everglades, but they had gained a window into its deepest secrets, an opportunity to coexist, predict, and manage. The pythons remained, powerful and adaptable, but their world had been illuminated. The swamp had been challenged, and humans had finally found a way to see its hidden truths. Were you amazed by how these robotic rabbits transformed the fight against invasive pythons and the discoveries they revealed in the swamp? Tell us which moment impacted you the most.